I'll briefly introduce myself and then we will straight away dive into the agenda. So, myself, D. Sai Natarajan. I have around 15 years of experience in software development. I started my career in TCS around 2010. And since then, I've worked on multiple different companies on multiple different projects. So, I've been working on AI-related technologies and machine learning and deep learning since 2015. And since uh, the major release of GPT models in the 2021. I've been working on generative AI as well. So I've been using generative AI for the last three years, roughly, and I've been doing trainings on AI and data science related as subjects for the last 6 years. And generative AI alone, I have delivered around 30 plus trainings so far. Okay, so that's a brief about myself, and this is the planned agenda for today's training program. So I'm supposed to plan to cover what is AI and how the market demand is for the AI related technologies, and try to understand the power and capabilities of generative AI. So that it will give you an idea of what are its current capabilities, where it's directing us, and how it will change the world. So that is what we are going to mostly discuss, and probably I'll try to invite you to have some discussions also. Eventually, we will have some question answering part also. So you can interrupt me probably occasionally if you have any questions, and also you can put any questions if you have on the chat, so that I will be monitoring the chat as well. If there are any questions, I'll try to answer them. But if you want to interact with me, probably let me finish a little bit of general introductions, and after that we will have some more interactions as and when possible, because the agenda is there for around 1.5 hours. But I have some demos as well planned. So we'll try to balance the time between my content delivery as well as for queries. Okay. So probably question answering, we'll keep it at the end. And mostly initially, I'll be starting with the content delivery. That would be the plan. So before we move on, if you have any inputs, if you want any particular topics to be covered more, if you feel that some topics, if you, for example, are very interested in, you can mention the same in the chat. I'll try to discuss about it as part of the generative AI or AI related introductions. Okay, so I'll probably move on to the content straight away, because this is a short demo. So overall, the time planned for the session is around 1.5 hours. So we have the session from 5 to 6:30. Okay, so let's proceed and start with what is AI. See, AI is a broad terminology to represent any ability for the computers to learn. So how is it different from general programming is, so AI systems can learn from data and take intelligent decisions. See, as a human being, how can we consider someone as intelligent? So we are living in a world which every day throws us challenges. So for example, even crossing the road, cooking the food with knife, everything is a very challenging task. Sometimes it is life and death kind of a situation when you just cross the road also. But we take it for granted. We are able to do these tasks quite easily. But you same at the same time, you put a robot, the state of the art robot today, whichever is the best robot available in the world with the best AI, it will still fail in simple tasks that we take for granted when we do it every day. So intelligence, if you consider what is the best supercomputer in the world, even today it is the human mind. So which means that humans possess immeasurable intelligence and capabilities that none of the AI systems are able to surpass our abilities so far. But that is expected to change in a few years. So AI systems are fast catching up, and we will see how and what is happening in the AI in the few minutes in the slides I'm going to give. But generally, intelligence or AI is nothing but artificial intelligence is nothing but the ability of the system to learn from data and learn from its mistakes. Right. So that is, so for example, you go to a new place, you are not aware of the place, you go to a park, and there is a stone which you did not notice. you step on it and you fall today. So next day you go to the same park, you will not step on it again, right? So which means that just one mistake is sufficient for us to learn how to change ourselves to a new environment. So that is intelligence. So intelligence is nothing but, we take some actions, that actions results in some rewards, which could be positive or negative. And based on that, if we can change our behavior to have a more positive world for a more comfortable life, that is what is learning, or that is what is intelligence. So the same way, machines are fed with the past data about any decision making system. So for example, in a banking system, it could be fraud detection. It could be, for example, loan approval system. In a retail, it could be about customer behavior analysis. So anywhere you look at the past data, look at what people have done, and know what you are supposed to learn. And next day, when someone submits a loan form, can you approve or reject automatically through a AI system? So that's what is AI, right? So AI can learn from past data. If a human takes a decision based on past history, his experience, then we can pass on the same experience that a human has as data to a AI system, and AI system should be able to learn from the data and take actions. So that is in general what AI is. And where is the need and market demand for AI is very, very high. So AI systems today, people who can do artificial intelligence systems, they can who can work on AI, particularly the most recent form of AI is the generative AI. So they have far more capabilities than previous generation models. Okay, so that is what we are going to see. So generative AI and large language models is the main use cases we are going to discuss in our today's discussion, because it has been quite popular in the recent times and everyone is very interested, uh, mainly because of its capabilities. So what I will do is I will try to show you current some explanations. I'm not sure how, I think many of you might have already used the chat GPT, but I'll just still try to give you some demos so that you will be able to get a grasp in case if anyone has never used ChatGPT. So these models can, for example, right now the GPT model that is available is the most recent version, which is the GPT 4o for Omni. So it can write programs, it can write content, it can write emails for us, and etc. Right? So let's see with an example. So I'm going to say write Python program to implement, let's say, a snake game. So if you see, this program will take at least around 6, 70, 80 lines of code. And it's not going to be fairly simple even for a human being to write. And believe me, the code that it generates, the AI generates right now, is coherent, it is syntactically correct, and it is capable of understanding the purpose and meaning of what it is writing. And that is how it is able to generate a code that will directly work. Okay, so as a human being, if we have to write this code, if we have to involve in this thought process, it's going to take at least 2 3 hours if we know what we are doing. So if you are totally new to snake game, probably it takes even a day, but AI system can do that in roughly 30 seconds, right? So that is the kind of capability that these models have right now. And so they can understand human language. And for example, if you are writing a mail, the mail you write to your friend, the mail you write to your colleague, and the mail you write to your client, each will have a totally different tone, different way of communicating, even though use case could be same. For example, you want to invite someone to have a dinner with you. So if you're writing the same mail to your friend, it will be different. If you're writing to a colleague, it can be slightly friendly but also professional. But if it is a invitation inviting to a client, then it's totally professional, right? So AI systems can totally understand all that as well. So this is an example. Roughly, I think it has generated around 200 lines of code, and I'm sure it will work. Okay, so that's a short introduction to what is AI right now. And you ask the same model to rewrite the same program instead of Python into, let's say, Java. It can do so, which means that AI systems can do code generation. But in general, what we can understand is it's like a chatbot, right? So mainly the way these models are trained is like a chatbot, where you give an input question and then the model gives you an answer. But it need not always be text to text. So for example, we can give an input as a text and the model can generate output as an image. So which means that there are AI models that can work across different input and output formats. So AI models generally are trained for text, as well as images and video, as well as voice generators, which means audio also it can understand, etc. So these are the common formats in which AI models in general work. And of course, I've showed you the example of the code generation capability. So when you start working with these AI models, these are some common names that you will see. So for example, the names that you see here are BERT, GPT, Llama, T5, Palm, and Bloom. So there are some alignment issues, but I think mostly you can read through it. So the GPT model is the OpenAI ChatGPT that you have already used. I have showed you as a demo. The precursor to the model is actually the BERT. So all these AI models are called as large language models. They have, for example, ability to have very high coherence and very high intelligent decision making knowledge. Okay, so they gain all this knowledge by understanding terabytes and terabytes amount of text. Okay, so what they are made to do is they understand human language, and also they have lot more research uh, introduced into their technology. So for example, they can have chain of thought. So chain of thought is nothing but if I ask you some complex question, you cannot directly answer the question in one processing stage. So we take several stages of refined output to finally generate the final output. An example could be I will show you some sample prompts where we can actually see the chain of thought. And there are several advanced prompting techniques that are available with which we can maximum utilize this knowledge that is there in LLM model. But these LLM models are, in short, the large language models are called as LLMs. And so they are very highly intelligent systems. So these are the model names that you will commonly see. To give you some idea, so for example, the GPT and BERT comes from the OpenAI. And eventually, since Microsoft is actually an investor in OpenAI, many of the technologies that are built in OpenAI will finally find its place into Microsoft. For example, the Copilot is nothing but a modified version of the GPT model, or major part of the technology that is there in the GPT goes into Copilot, which is mainly used by Microsoft in Azure as well as in their Microsoft suite of products. So the Palm model is actually from Google's research, and the Llama model is actually from the Facebook or Meta research, right? So these are the major companies that are pumping massive amounts of data into this technology. So ultimately, I'll also give you some technical terms. The LLM models, whatever input we give as a chat input, they are called as prompts, and whatever output we get from the model, they are called as completions. Okay, and there are some limitations as of now in terms of how many words you can give as input or output, which is controlled by some term called as context window. So for example, an older model of GPT-3 would have had a context window of 1000 tokens, but a GPT-4 model that we are using right now will have a much larger context, like 4000 words or more. So you can actually check the documentation of each model so that you can understand how long an input or output from the model we can expect. Okay, so ultimately prompts and completions are nothing but the input given to the model, and the produced output have some limits, and this is the prompt and completion kind of like a flow. And There are several use cases with which you can actually work with prompts. So for example, we can actually ask it to write essays or create content for email marketing, etc. It can also do the reverse. It can be given some text and you can ask it to explain what it is. You can ask it to interpret the meaning of it. You can give some code and ask it to write comments, etc. That is summarization. And then you also can do language translation. So as I said, you can actually give some text in English and ask it to convert to either German or Japanese or French, or you can also give a code in Python and ask it to convert to Java or vice versa. Okay, so they can do language translations. and also they can be useful for information retrieval. So information retrieval is nothing but, so for example, you have a 500-page technical document which you don't know anything about. Then what you can do is you can actually feed that document to the AI, and now you can ask questions. So what is you can ask what is the text about, and you can give a technical term. So for example, what is an AI model? What is generative AI? What is a large language model? So then the model can actually look into the content that is there in the text, and it can give you an explanation of what's in it. Right. So it is like a conversational AI. So where you can convert any enterprise data that is there in your organization, feed it into the AI model. Now you can converse with it. So that it actually is a very powerful solution. And usually for anyone to adopt a generative AI, this is the first way we introduce AI to the system, to the company, right? So because RAG, so this is information retrieval in short is actually called as retrieval augmented generation, where the AI's current knowledge is augmented with the information that is there in your input data. Now the AI looks into your data and can gain information or knowledge from that document, and can now give you answers to the questions that you pose on the information that you have fed to the AI model, right? So it's going to be, for example, you can easily build a customer support chat systems with it. You can also build decision support systems where you can actually ask AI whether to do something or not to do something, whether something will work or not. And you can also feed your code to it, and now you can actually ask AI to give a better version of it or debug something, or you can even ask it to generate comments, do code review. Anything can be done using this kind of a information retrieval system. Lastly, you can also use the AI to actually take decisions. They can call external applications or APIs. So for example, in a chatbot system, let's say the customer asks in a retail system, imagine you have an e-commerce platform. So the customer is asking, what is the status of my delivery of a particular product I bought? And AI finds the information and says it is going to take 3 days, and the delivery is delayed by 1 day. So then now the customer is not happy about it. He asks you to cancel the order. Now the AI can actually go ahead and put the order status as cancelled, and initiate the cancellation of the order. Right. So even such kind of a decision making now the AI can do. Okay. So apart from all of this, as an enterprise, what are the other things AI can do is the AI can actually do code generation. So which we have already seen, and so there is a AI model that is directly integrated with the IDE that is available. Particularly, for example, we have a model from Microsoft which is called as Copilot. Copilot is very what do we say, directly integrated with the IDE, and it can be very helpful for you to accelerate your code and programming and code generation. Okay, so there are uh, multitude of ways in which AI is going to be imported into our platform. Okay, so that's a brief about what AI is actually capable of doing. So they are capable of generating text, but you have to give the full information. So for example, you say, how will my tea taste? It might say great, but you give further information. For example, the milk is bad. Will How will the tea taste? So it will give you, for example, it's not going to give you great. So which means that AI models can actually, it's not just a bunch of text that we give, and it directly gives you an output on a text input plus. So for a given input, this is the same output always. It's not the case. So they actually understand the real meaning of the words, and they have a good amount of reasoning to produce any output that we give. One more such example is text is always very difficult to understand. And one of the reasons is mainly because the same word has different meaning in different sentences. So for example, I can say I took the money to the bank. So now, is the bank representing a river bank? No, right? So the same word bank has 3 or 4 different meanings in different context, right? So I can bank on him. So that is different, right? So where it is reliability of a person, right? So basically you can see that the same word has different meanings in different context. So that's where building a proper AI system that can actually understand text is a very, very, very complicated situation or a complicated problem to solve. And sometimes what happens is the text may also have inherent missing information also. So for example, an example of such missing information is given here. So the teacher taught the student with the book. It has some information, but is the book belong to the teacher or the student? Again, that is ambiguous. That is not there in the text. So there are several challenges that you will face in understanding text. And that is why previous generation models, AI models, were never able to properly comprehend the complexities of text. So, for example, I've been working on chatbots and text for the last 10 years since 2015. And there were AI models that were built even in 2016, which were used as chatbots. But they were very limited in their ability to understand this kind of a complex problems in text. And they were very limited in their use case. So, for example, those chatbots were mostly never used in production. And by around 2020, even if some of the old models were refined and used, they were very limited in their abilities. But right now, if you have used ChatGPT, you can see that they are very coherent, highly intelligent, and they can pretty much understand anything, and they are always able to give you an accurate answer. So that kind of a AI was possible only with this new generation of AI model, which is actually called as transformer. So the transformer model has few advantages compared to original chatbot models that were built around 10 years back. So the few of the important changes that were done recently to get this kind of improved performances are, there was a concept called as attention that was improved. So for example, the concept of attention was introduced around 2015 itself. So what is attention is nothing but, so for example, you have a book that you read, and someone is asking you a question. So now you will give an overall overview, but you will not be able to give very accurate answer. So what do you do? So you open the book again, you go to that particular chapter, you reread one or two sentences. Now you can give a more accurate answer. So which means that you have been trained with large, vast amount of information, but someone asks you a question. Now what you can do is you can actually go to some relevant information and look at it and get access to that and reread the information, and you can answer it better. And more importantly, you know what rest of all the entire book is ignored, and only the sentence that is important to answer the question, you are reading it again. So the attention mechanism in general is the same. So the attention mechanism helps the model to focus where important information in the input is given, and ignore everything else in its knowledge which is not necessary to answer the current question. So the improvement in the attention mechanism was happening, evolving in the last 10 years. And the current level of attention, which is called as multi-hidden attention and self-attention, there were many technical papers that were involved in all these improvements. And these have tremendously increased the coherence and the ability for the model to correctly answer the question. And secondly, the transformer architecture itself is found to be very suitable to be trained on very large amount of hardware. They can be trained in parallel, and some network architecture improvements that were made to make them generate data. And more importantly, all these generative AI models generate one word at a time. So you can see the output, which is at the top right corner. It says softmax. The softmax is nothing but it generates one word at a time. So how this works is basically the word, once it generates the first word plus the entire input is given back to generate the next word, and so on. So which means that since the model has all the thinking ability to generate what is the next word, it is not concentrating too much on what is the 100th word it has to generate. It has to just focus on generating one word at a time. And that also improves the model's ability to coherently produce the sentences better. Okay, so these are some of the improvements. So transformers, with the introduction, they were able to scale better. They were able to get trained parallelly across large amount of hardware, and they were able to give full attention to the input meaning of every word, so that they were able to produce more accurate sentences. So these are some of the advantages of using LLM. So when we talk about transformers, you can see that. So for example, that word, if you give a sentence like teacher taught the student with the book, so you can see that the word teacher, taught, student, book, all of them have relationship with each other. So the transformers with this attention mechanism is able to understand the interrelationship between every word in the previous word, not just the immediate previous word or the immediate next word, but the entire sentence, every word that is there in it, it is able to give attention to all of them. So that is the reason it was able to generate code also more coherently. Because when you write a program, even a single variable that was created 100 lines ago is still useful and important to generate the next line, right? So if you have to have that kind of a programming ability, then you should have the knowledge about the entire input sentence, not just from the user question, but also the previous words that you generated is also very important. Right? So that is the reason they're able to perform this. So you can see that the attention map of the important words, you can see that in the brown color lines, right? So it is able to identify what words are having relationship with what other words in the sentence, and through their attention and importance and meaning that they understand, that's so they are able to generate more accurate information. So what they do is basically they look into the entire sentence, and for every word, what is the other word to which they are related to. So they are actually doing a map. So this process is called a self-attention. And using the multi-headed self-attention mechanism, so that's where they were able to give a coherent output that they were able to generate. I think I've been continuously talking a lot for the last 20 minutes. I'll see if there are any questions that you have had so far. There is some information in the chat. Yes, I think the session is recorded. There was an input LangChain to be covered. Yes, Vinod, I'll be covering a demo of LangChain. Let me see if there is any other questions. Okay, so I don't see any questions. I'll try to move on. So you can also let me know. I'm again giving a presentation which is very generic, that even if you have no prior knowledge of how these models work, I'm trying to give you information about everything. I'll try to give more demos after another 15 minutes of further presentation. Okay. So ultimately, the transformer model has two major components. There is network part, which is on the left, is actually the encoder, and the network part on the right side is actually the decoder. So how this works is basically the actual user input goes to the encoder, and the final output is generated from the decoder. So why do we need two components? Is basically for the model to actually better comprehend how to generate the output. I'll give you an example. If I ask you, how are you doing today? And today is a very bright sunny day and you have a very pleasant day. So you'll say, I'm doing great, I'm doing fine, I'm very happy. So, but whereas if let's say tomorrow is a very dark day, for example, it's a Monday morning, we have a lot of work, and or for example, it's a very heavily raining, then you will not say still, when I ask you the same question, how are you? The answer will be different. So which means that for a given input text, always output will not be the same, right? So which means that there are a lot of what do you call? So basically, thought process that has to go in answering a particular question. So text is always not one-to-one relationship. So several words before and after the current word has a lot of significance over it, and our thought process associated with those words are also important. So that is the reason they have split the overall network into two parts. The input that is given to the encoder converts the input text into some kind of a thought process. So that's what the encoder does. It converts the input words into thoughts or thought vectors that goes in our brain. And then the decoder part uses the input from the encoder or the thought vectors, the processed information, and produces the output words. So that's the reason we have two parts. Encoder will convert the input words into thought vectors and thought processes, while decoder uses those thought vectors plus the previous generated word to produce the output. So that's how it works. So, and one important point is any AI model is all built and working completely in mathematics. So a lot of mathematical derivations and things are technologies are involved. But roughly one important point is, if you give an input as a word, the model does not understand it as a word. It actually understands it as a number. So which means some kind of a conversion has to happen, which will convert our input words into numbers. So for that, there are two parts that are involved. One first part is actually tokenizer. So what it does is every word, a unique identifier number will be given. It is like employee ID for a person. So every word will get a unique ID. So that is called as tokenization. And but just giving employee ID kind of like token IDs is not sufficient to train a model. So the reason is, even though the ID is a number, you can see that the word the and the word teacher, they have two different numbers. and each word has a meaning, and one word is one number numerically is higher than the other, but every word is same, right? So basically, if I put a number, then they have some significance in terms of the value, right? So for example, 342 is less than 879, but the word teacher and the are they do not have that kind of a which is higher or which is lower. So which means we cannot directly use these token IDs or unique identifiers for the words directly to feed a number, feed it as a number to the model. So for that, we do one more thing, which is actually called as embedding. So what the embedding process does is, the embedding process converts every such a token ID that is given as a number into more meaningful representations. And that meaningful representation is actually called as embedding process. I'll give you an example. So for example, let's say there is a sentence which is king. So what is a king? King is nothing but a ruler. And plus, it also has information that he is a male person, right? So whereas if you say word queen, she is also a ruler, but it represents the word queen represents the female gender as well. So which means that the queen and king commonly has a ruler. So if the word king is mathematically represented somehow as a number, I should be able to do vector math. So for example, I can actually take the word king and subtract man, and then I add women. Okay, so for example, instead of male, I'll call it as man, and then instead of female, I'll call it as women. So that way it will become more easier. Or the other way around as well. So for example, I can remove the male part, and if I can add the female as information, and what will the result value? So from the king, I removed the male, which is the gender, and added a new gender, then this should produce me the word queen. And it has been mathematically proven this is possible. And this process is done using a feature operation which is called as embedding. So what is embedding is nothing but converts tokenized information. Okay, so which means that the words are already converted into IDs. So tokenized words into meaningful representation. Okay, so meaningful numbers. Okay, so as vectors. Okay, so usually they are vectors of a multi-dimensional array. So for example, a 10 by 10 array is what usually these embedding processes do. So which means what they do is they convert a word into multiple set of numbers, such that one, for example, they are called as dimension. One dimension might actually capture the meaning about ruler. Other dimension might capture about the information about the gender, and so on. So for example, every word that is there in the sentences that we speak, they have different aspects in different context. And as I said, for example, the same word bank has a different relationship and different meanings in different sentences, right? So then what happens is they have interrelationships with other words as well. So all of that is properly captured when we do word embeddings. Okay, so ultimately the purpose of this embedding process is any mathematical AI model cannot understand words directly. So what we do is we take the words, tokenize them into IDs, numbers, and then those numbers are again converted into embedded vectors. These embedded vectors will be multidimensional numbers such that they actually have the relationship, and they know the original meaning of the word. And the embedding process itself is done with another model. Okay, so but ultimately these all gets converted to numbers. That's what I'm trying to convey. So this is how ultimately a number will look like. Okay, it is a multidimensional array. So once the words are embedded into numbers, they are fed back into the model as input. So for example, how they are trained is the word student and book. They very frequently appear together. So in that case, in the embedding space, they'll be very close to each other. Whereas the word, for example, fire and student may not be as frequently appearing as student and book. So in that case, you can see they are far apart. So what they do is when you feed a lot of sentences and the words in those sentences, the embedding process actually understands the meaning and relationship between those words, and they in the vector space they put those words that are highly relevant to each other very close to each other. whereas the words that are not so relevant to each other, they'll be far apart. Okay, so that's how they actually represent the meaning. And internally, mathematically, there is a process which is actually called as cosine similarity, or basically they understand mathematically what is the angle of relationship between them, and that's how they do it. Now, this is again some more internal information which I'll skip. But ultimately, this embedding process is very important, and the more accurate the embedding process, that much only the model can actually properly understand the information. And also, as I said, the same word has a different meaning in a different sentence. So the same word bank, if it appears at the end or if it appears in the middle of the sentence, it could be used in a different context and purpose. So what they do is they take the token embedding, which is actually the meaning of the sentence, plus the positional information about the word, so that you know where in the sentence it is present, so that you have additional information to understand the better understanding of the word. Okay, so they do something which is called as positional encoding, which represents the exact position of the word in the sentence to properly put that as an input. So after giving all this information, so you converted the input words that is given to the model and into embedding vectors. Now those numbers are finally again given some attention mechanism, so that it knows where in the input word you have to focus more to produce an output word. And after that, you finally produce the output in the softmax layer. So as I said, we'll see one example of how the entire process works. So you have an input sentence, and now you have to do a language translation. So that's what we are going to do. So the input words you can see is on the left, and those sentences converted into words. Words are converted into tokens. Those tokens are embedded into, again, meaningful representations as numbers, and then finally sent to the encoder. So encoder will now convert the embedded inputs into thought vectors, some kind of a processed intermediate information. Now the decoder will get those thought vectors from the encoder. Now you start with generating the first word. And once the first word is generated as input, then the first word will be given as input, plus the thought vectors will be generated to produce the next word. So which means that every word is generated one word at a time. So and then you produce the next word, etc. So for producing every word, the previous thought vectors from the encoder plus all the input generated output words are given to produce the next word, and so on. So which means that every generative AI model or the transformer model is actually generating just one word at a time. So that's what they do. And after all the words are generated, now you convert those output tokens into words again and give that back to the user. So this is how the entire prediction works. So now the question is, how large are these models? They are very, very large models. So I'll see if I can go back to that particular slide where there is a comparison. Yeah. So you can see that these large language models are evolving to become bigger and bigger. So you can understand, for example, a 1.5 billion model has lesser computational requirements compared to a 175 billion parameter model. So what is exactly a parameter? I'll try to show you a little later. But ultimately, what you should understand is the larger the model, they require more computational resources to run. So now what happens is, but the model has more complexity, has more ability to learn from more amount of data, right? So right now, the evolution of AI models is such that in the last 3 years, the models have become bigger, and their ability to cognitively think and produce coherent answers or outputs are becoming better and better. Okay, so that is what you can understand. So now what happens is the entire 175 billion parameters is nothing but the number of parameters that is there in the model. And now you have to do a mathematical operation for every parameter to produce output. So which means that if there is a 175 billion parameters, you are doing 175 billion computations to produce one word. So now if you are producing 100 words, you are doing 175 billion computations multiplied by 100. So that is the reason every word is very, very computationally expensive to generate. So any AI model you take, their pricing calculation will be based on the number of words you generate. So each word you compute is actually you are paying for it. Okay, and another important point is the more words you give as input, the more computations the model has to do. So in that case, what happens is the input is also charged. So for example, you give 100 words as input and you produce 50 words as output. For those 100 words, you're paying in some part of your payment, and the 50 words that is generated output, for that also you're paying. So which means that you're paying both for the number of input words plus the number of output words, because each, as the input words and the output words increase, each one of them will require a lot of additional computations to be done. Okay, so that is what I wanted to say as general introduction so far. So what are the information I have given is that these models are made of two components, encoders and decoders. Encoders will convert the input words into meaningful thought representations. Decoders use that thought plus the previous generated output to produce a next output word. Okay, so that's what they do. And there are some different versions of it. So technically, I'm skipping that because of lack of time. So okay, so a lot of times what happens is each person will use the same model for a different purpose. So for example, I want to use LLM model to do sentiment analysis. Someone else will want to do fraud detection. Someone else will want to do some other purpose. So in that case, I cannot train an AI model to do everything separately. So what we do is we generate one single model that is capable of doing everything. So these models are built as artificial general intelligence. Again, they are not fully achieved this objective yet, but what they are trying to build is actually called as artificial general intelligence. So which means that one single model knows all, does all kind of a AI is what they are trying to build. In short, it is called as AGI. So if you look for more information about AGI, you will kind of like understand where this AI models are eventually leading us into. Okay, so ultimately, what you will see is if you can, for example, hire a person who has around 10 years of industry experience. So that is like getting a pre-trained model. And then what you do is you you give him 1 week of training as an orientation. So what are you orienting him into? Into your current project's information, right? And after that 1 or 2 weeks of orientation, now he becomes ready to contribute to your project, right? So the same way, the pre-trained model is like the 10-year experience guy. And you have to do project specific data loading, and that adaptation can be in multiple ways. So the pre-trained model already has a lot of information. Okay, plus you do one of these. So either you perform something which is the information retrieval operation, which is actually the RAG. So we have vectorization to feed information. Okay, so information as vectors. So you can give so that you can do RAG. So this is one way. Another way of giving your enterprise information is you can completely retrain the model. Okay, so it is actually retraining is actually called as fine tuning. Okay, so you can fine tune a model to make it understand your project data better, or you can actually you have one of these two choices. Alternatively, what you can do is you can train the LLM model from scratch. So this is the third option. So which one is more feasible is, as of now, this information retrieval and model retraining, fine tuning as per your use case. These two are quite inexpensive. So for example, if you try to understand the cost, so this information vectorization and retrieving will just be costing you, for example, as a project, even if you do, you can do it at around $10,000. But if you want to do a fine tuning, usually you do it for a much larger purpose. Okay, so your input data is high and you have a lot of domain adaptations to be done. So then somewhere between, for example, a project between $10,000 to maybe $100,000. So that's where you will typically do fine tuning. But if you have a project which is more than $10 million, okay, so that's when you can actually do a from scratch training of LLM, okay, because LLM models are very, very expensive, okay. So project value is greater than, for example, $1 million at least, right? So that's when it becomes valuable to actually train a model on your own. But there could be some use cases where you don't even have the $10,000. Is there anything that you want to try out as a POC? So that's where there is another adaptation that is available, which is called as in context learning. So what is in context learning is nothing but within the model's input itself, within the input you provide to the model, you can directly ask the model to do certain tasks. Okay, so anything less than $10,000 probably, this is what you can actually do. An example is, for example, I can say, um, classify this text, okay, this piece of text, and I'm saying I did not like this chair. Okay, so you can see there is a review that is available in an e-commerce platform. You take that, and then you are asking for the sentiment. So what is the sentiment you get? So you can either say it as positive or negative, right? So this is what you will say. So in this case, this is the output you want. For that, what you're saying is you are giving a hint. So what are the information that is there? So this is called as in context learning. So in context learning means as part of the input text itself, I'm giving a lot of information to the model. So what is the information I have? I have a information saying what I want, and then I'm having the data on which this instruction has to be applied and how to format the output. So the output formatting has to be as a sentiment. So either it has to say it is positive or negative. So this is this type of information where I provide these three information. So I'll even put this information here. So this is the instruction on what you want the model to do. And this is the data on which the model has to produce, perform this instruction. And lastly, this is the format in which the output you want. Okay, so you can see all these three information is there in the prompt itself. So this is called a zero shot learning. So zero shot learning means I never even gave a single sample of this is the input and this is the corresponding output. I never even gave that. So the model can directly understand for a simple use case like this what it has to do. But sometimes what happens is the context exactly what I want may not be understood by the model. So in that case, what I can do is I can actually provide a sample and a corresponding uh, output. So here, if you see, this is zero shot learning. One shot learning means sometimes in zero shot learning, the model does not really understand what to do. So in that case, what you can do is in the prompt itself, you can provide one sample input and corresponding output. So you can see on the left, the prompt, we are saying classify this review, and the input is I love this movie, and sentiment is positive. So which means that I'm saying what I want, either it should be saying positive or negative. So now I'm asking review, classify this review and provide one more review, I don't like this chair. So in this case, the model can give me the output as negative. So this is called as one shot inference, where the first input that is given here, I'll try to see if I can annotate it. So this first input here is the one shot that we are providing as a sample. So this is the instruction, this is the data, and this is the corresponding output we want. So we have given one sample, and now we are asking, this is the actual data on which we want the model to do the prediction. And then you can see the model gave me the prediction as negative, right? So this is another way of giving more information to the model. So this is called as one-shot inference. But again, if you see, okay, it knows what to talk about positive, but I think that I want the model to give me negative as the sentiment of if there is anything negative. But what if instead of negative, I want some other word as an output? So in that case, what you can do is you can give 2 or 3 samples and corresponding outputs representing all your use cases. So what is positive, what is negative, and also you want some neutral information to be captured, then you can provide all of that. So now what happens is after providing multiple samples as inputs and outputs, now you ask a question about a particular sentence. The model finally understands based on all those inputs, it has to produce this kind of an output. So we are actually kind of teaching the model itself what kind of formatting it has to do, how it has to interpret the information. So all that information we are directly giving as part of the data itself. Okay, so prompt itself. So this is called as few shot learning. So as I said, using the prompting technique itself, you can actually get the output you are looking for. Okay, so that kind of a project, if you can do in context learning and prompt engineering, right? Just by asking the right prompt, you can extract mostly what you want. So if you can do that, then those can still be an AI based project. It can be a POC. You can do it with very, very less cost. But a lot of times what happens is the entire data that on which the prediction has to be done will not fit into the context window of the input or the output size the model can understand. So in that case, what you have to do is you can actually do a RAG. But RAG systems are only for information retrieval. They cannot actually modify the model's behavior generally. So if you want proper understanding of the project and, for example, go for a much more complex type of prediction. So in that case, what you have to do is you have to go for fine tuning. So fine tuning will require some understanding about, for example, deep learning and how to train a model. That kind of a deep knowledge is necessary. So which means that prompt engineering can be done even by non-technical people. Which you already know. But whereas the information retrieval, retraining, all these will require huge amount of knowledge and depth of information. You should have prior knowledge about machine learning and deep learning if you want to do any of these three tasks. But first one is like the low hanging fruit. Anyone can directly do. So if you have used ChatGPT, already you know that. So your model automatically understands mostly what you want, and you can directly provide the information and get the information you want from the model. Okay, so that's a brief about what these models are. So in general, how will a generative AI project lifecycle will look like? So basically, you define the scope, what you want to do, what kind of information prediction that the model has to give. Then there are enormous number of models that are available in the industry now. So then you have to choose what model should I use. So that is something that you have to choose. And after that, either you can just simply get the output you want from prompt engineering, or you have to do some fine tuning. And sometimes there are techniques to align the model's behavior based on human feedback as well. So the model understands your input, whether it's predicting correct or not, you can give. And based on your feedback, the model will correct to itself to produce a better output. So that is alignment with feedback. And then what you do is after making all these changes, now you have a model that is modified from the original knowledge. Right. So the pre-trained model is now modified either doing fine tuning or with human alignment. So now with the modified model, you have to do evaluation. So is the model accurate enough to predict the output I want in production? So after you evaluate the model for accuracy, if the model is accurate enough in predicting what you want, then you can actually optimize the model to run better in production. So for example, if you are training a model, it takes 20 times more resources to train the model than to run it in production. So which means that if you know how to run it normally in your laptop, it doesn't mean you can directly run it the same way in production. So you have to optimize it to use less resources, give output faster, etc. So you do those optimizations, and finally you put the model into production and integrate it with your application. So this is the final stage. So these are the overall stages in which you have to think about any generative AI project lifecycle as. Okay, so let me just see. Yeah, so you will mostly go for a pre-trained model, but there are some ways in which you can customize the model, custom LLM models by fine-tuning it, or with human feedback, or with some fine-tuning from data sets, etc. Okay, so there are two options. So foundational models are nothing but pre-trained model. Like you take the GPT-3 model or GPT-4 model, you can directly give your input and you will be able to get the prediction. But if it doesn't directly understand your enterprise data, then you have to go for fine-tuning, which is building your own custom model. So which is nothing but a modified version of the pre-trained model. Okay, so it is like, for example, taking a 10-year experienced guy. Now you go take him through the orientation program. So after 2 weeks of orientation, he has more knowledge about your project. So that's what is building a custom model, or a transfer, fine-tuning the model to adapt to your custom user requirements. Okay, so that's about it. And so basically, yeah, I'm coming back to the same slide. So the first chatbot model that showed significant improvement and significantly producing coherent output was the BERT model, which came from OpenAI around 2018. And that's where people were realizing the potential of AI. Right. So then OpenAI worked and produced the next model, which is a GPT-2 model, which had 1.5 billion parameters. So what is a parameter is nothing but basically you can understand all these models are mimicking human brain. So for example, in our human brain, we have brain cells which are called as neurons. So one neuron is a very small computational component. So now what you do is, if let's say you even decide, so today for dinner, what are you going to eat? For example, you have few choices. You can eat dosa, idli, pizza, etc. So you put all those choices. Now you take them through your thought process. Now you finally you come out with something. So based on the climate, based on your mood, you decide to and your budget, you decide something. So now what happens is, to make this decision in our human brain, we at least utilize around 50 billion neurons or more to make this decision. So you can imagine, just to decide what to eat, there are so much computations happening, so many different possible angles we are thinking to decide what to do, right? So similarly, the more neurons involved, the more actively you do computation, more accurate you are able to produce output. So the same way, the larger the model, it is like using more neurons from your brain. So the larger the model, the more accurate your output is, and more concentrated, more computationally accurate results you can produce, and their ability to think, their ability to cognitively understand different aspects. As I said, the your apart from your mood, for example, what is the budget? What is the cuisine? And for example, how far is it from your place? And how is it tasting? So all that is involved. So these are all different aspects, right? So the more neurons you involve, the more among these information you can feed to it and produce an combined result. So which means that the larger the model, it will have more cognitive thinking ability. It can put in more input information to produce a more accurate answer. So which means that is the reason you can see that these models are evolving to become bigger and bigger. So, but what is the problem? If a GPT 1.5 billion parameter model takes $1 million to train, a GPT 175 billion parameter model will take $20 million to train. So, which means that the larger models will require insane amount of money to train. So, for example, as I said, the GPT-3 model took around $19 million just to buy new hardware to train it, because it won't fit into any of the existing hardware, right? So, which means that as the models become bigger, they'll require more and more hardware to actually train, right? So ultimately, where we are heading right now in 2023 and 2024, the models have reached the size of trillion parameter model. So for example, the GPT-4 Omni is a more than a trillion parameter model. So you can see that GPT-4 model is much better compared to GPT-3 or 3.5 turbo. But what is the problem? They are more expensive as well, because it took insane amount of money, much more amount of hardware to train these models, right? So that is the reason they are very expensive. So for example, if you take 1 billion parameter, so one parameter is nothing but a one floating point variable, so which occupies 4 bytes in memory. So if you have 1 billion parameters, then it occupies 4 GB of RAM. And usually these models are run on GPUs or graphics process, and because it is faster to run it on GPU. So now you require 4 GB of GPU RAM to load 1 billion parameter model into the memory to run prediction, right? So now what happens is, to train the model, it has a lot more information to process. So for example, if you run it in prediction in production, if it requires 4 GB of GPU RAM, to train this model, they require 80 times more resources. So which means that the same 1 billion parameter, if it requires 4 GB GPU graphics card to run in production, it will require 80 GB graphics card to run the same 1 billion parameter in training process. So training process is much more expensive and requires a lot more resources than to run it in production. Okay, so which means that to train a same 1 billion parameter model, if it costs $1 million, to run it, probably it will just cost you $10,000. So that's the difference. So training is much more expensive. So there is a process which is called as quantization, with which you can actually run the same model with less resources. So for example, if you run the model in full precision, which is 32-bit, if it requires 4 GB of GPU RAM, you can run it in half precision, which is 16-bit floating point, and your resource requirement will become lesser. And you can even quantize it further to integer values like int 8, and your resource requirement will become even half. So these are levels of quantizations you can do. So I've done even int 8, even int 4 type of quantizations are done to reduce the model size to much lesser to run better predictions. Okay, so quantization will result in some drop in accuracy, but mostly they are coherent enough even after quantization to run in production. Okay, so these are all the different ways in which you can do quantizations, and the floating point into half precision is quite normal that people do to run the model in production, to have less resources. So for example, the same 1 billion parameter model in full precision, if it requires 4 GB GPU, with a half precision, it will just require 2 GB of graphics card, and with int 8 quantization, just requires 1 GB graphics card to run. Right. So these are the points. So which means that even you can take a LLM model, run it on your graphics card on your laptop, and it will still work provided you do quantization to the sufficient level. Okay. So what are the significance? To train a 1 billion parameter model, if it requires less amount of resources, for a 175 billion parameter model, it takes around 14 terabytes of GPU RAM to train the model, right? And for a 500 billion parameter model, it takes 40 terabytes of GPU RAM to run. So imagine, so which means that around 10,000 or 20,000 graphics cards are used to train a model like GPT-3. So now you can imagine the resource requirements for a GPT-4 model, which is a trillion parameter model. So they are very, very expensive to train. So these models are trained with 20 million to 50 million, even $100 million are invested to train, to purchase new hardware to just train a model. right? So that's the reason they are insanely expensive to train. So that's the reason people do not train the models on their own. So there are also other reasons. So for example, there are ways in which people are trying to do one more research. So ultimately, people also want to run their models on the laptop. And for example, a code generator model. So it is better to run it directly on a laptop than to run it on the server remotely. Another point is there is a concept called as edge AI. So which means that the robots of tomorrow, they are going to be more frequently going to interact with us. So for example, you would have heard about Alexa. It's just a device just stuck somewhere and trying to converse. But imagine there is a moving robot. So for example, you replace your maid with the robot. Or in a factory, one of the person who is going to do very dangerous jobs, he is replaced with a robot that's going to take that dangerous job. High temperature work, etc. So even self-driving cars. So what is going to happen is there are going to be robots that are going to interact with people and going to be very, very close to each other. They are going to run, walk, and interact with us. So in that case, we want to run these large language models on inside those robots as well. So that's where you cannot have that trillion parameter model running on a robot. So you need smaller LLM models to run inside those robots. So that's where the research of reducing the number of parameters is happening. So for example, there was a research that showed that Llama model, there is a 7 billion parameter Llama version available. Llama model with 7 billion parameter outperformed GPT-3, which had 170 billion parameters in many of the metrics on accuracy. So which means that smaller model is not always worse in its performance. Sometimes by training the same smaller model with large amount of data for a longer time produces better results than a larger model. Okay, so small language models are also coming into picture, like models with around less than 7 billion parameter. Even 1 billion parameter LLM are getting popular recently. So I've run them, and they are not as comparable to LLM model, but they are still good enough for many of the purposes. So for example, you have a DevOps engineer. He's going to run kubectl create deployment. So you can see the amount of technical words, the what do you call, so basically the dictionary, the number of words, unique words that are used in a technical use case is very less. So in that case, can you use a 1 billion parameter model or lesser, which can understand better some technical inputs and only do that particular task? So in that case, it will be much better in computational efficiency to run to do that task compared to full-fledged LLM. So for example, to run a kubectl command, you don't have to understand how to write a poem or how to write a tweet, right? So whereas the large language model has knowledge of everything. So what you do is you have purpose specific solutions that you can build with these smaller models. And this is again an active research where you have smaller models, but good enough to be used for a certain specific purpose. They will not have all the abilities and all the accuracy of a large language model on everything, but they can be accurate enough to do certain tasks confined to a specific use case. So small language models and LLMs with a less number of parameters, less than 10 billion parameter model is a very active research, and a lot of activity is happening there. So if you have time, for example, check with the Llama models. You have 7 billion parameter, 13 billion parameter, etc. So those models are very good in doing tasks which are commonly necessary for us. Okay. So again, another final point that we have to know is there is a concept called as domain adaptation. So which means that um, you take a LLM model, it knows everything about general things like how to write tweet, how to write poem, how to generate code in Python or Spring Boot, but it may not be accurate enough in understanding a specific domain. So for example, there could be proprietary information only available within your organization or within your client's organization, and you want the model to understand their technical terms. So then what you can do is you can do something which is called as domain adaptation. There are again different ways of doing it. As I said, one of the ways is fine tuning it. Okay, so now what you can do is you can adapt the model to a specific use case so that it can do that particular task better. So you take the same base model like a GPT-4 model, you fine tune it for legal purpose. You fine tune it for healthcare to understand medical language, etc. Because sometimes what happens is the same word will have a different meaning in different um, fields, right? So what you have to do is typically in the near future, the current year or in the next 1 or 2 years, you will see a lot of domain-specific models that will come into the organization, and those adapted models will be used. For example, when I went into another company, which is Society General, so they were not allowed to use ChatGPT, but they had their own version of ChatGPT that they can use. So which is nothing but domain adapted to their company's rules. But similarly, you can also adapt it to generic domain specific information as well. And these are the current set of tasks that LLM model can use. And this itself will give you a large capability of what these models can do. But as we proceed further in the next few years, its potential and capability is much higher and could be used in many, many different ways. And one of the important ways is again the robotics that I was talking about. Okay, so I think I have mostly done conceptually what I wanted to discuss. So I think I have explained in general what is generative AI and how the technology in general works. And I've also given some details about prompting and prompt engineering. I haven't given much details. Probably prompt engineering, we'll see some demos now. And then use cases and applications of prompt engineering. I've given information retrieval, customer chat support, and augmented information running on edge devices as part of an AI. And also it can also be used for purposes like domain adaptation, code generation. There are many, many, many use cases, right? So the future trends, as I said, one trend is to build larger models and use it as a much more artificial general intelligent system is one option. The other, you have seen that we are building smaller and smaller models which can run on smaller and smaller devices like laptops, desktops, even small embedded systems where they can show some intelligence. So for example, you have AI enabled TV. You can have AI enabled phone, right? So similarly, you can have an AI enabled fridge. So it automatically decides when to increase or decrease the temperature based on the outside climate, right? So every device around us is going to become intelligent, and they're all going to have some part of this AI system infused within them. Okay, so that's the kind of future that we are going to see. And there are some ethical concerns. I think last 10 minutes I'll keep for ethical details. But as of now, I think I'll show you around 15 minutes of demos, different demos. Okay, so there were some questions which I missed. I'll try to answer them before I move on. So how does the max work? We talked about building context. So basically, the idea is when we generate one word at a time. So what happens is each word is used using the entire model. So all the parameters are used in the computation to produce each word. So that's the reason the larger the amount of sentence, longer the sentence that you're generating, the more expensive it becomes, as well as it's going to take more time. And so the max tokens is based on a few things. One is the model itself will have some limitations. So on max tokens, and the other is while running the model, you have some options. For example, if you check the GPT model itself, there is one version of GPT model which gives you 16,000 tokens as input or output. There is another version which can even have double or triple that value. Okay, so the configuration with which the model is loaded into production, that will also have an impact on what is the max tokens that you can have. Okay. Next is how to solve hallucination problem. See, there are some ways to solve. One of them is actually to work, for example, instead of actually relying on purely on the model's output, you can also give some vector information and then use like retrieval. That is one of the solutions so that you are more safer. But technically, there are few more ways in which you can solve, but that is beyond our scope of discussion today. So how to convert text into vector? As I said, there is a process which is called as embedding. The embedding process is what actually converts the text into vectors. And so again, similar to the large language model, even embedding is actually a model. So which means that there is another neural network that is used to actually convert the text into vectors. Embedding is again a prediction only. Okay, so how it will handle synonym words? Again, as I said, every word it understands in the embedding space. So the model is actually going to convert your words into numbers, and within the numbers, it actually knows the relationships and meanings between them. As I said, in the vector space, the words that are similar with same meaning will be very close to each other. Okay, so and by that it can understand that the words are same or different. Yeah, all the presentations used during the session, I'll be sharing it. How can we integrate AI to our business apps? Produce, as I said, for example, what you can do is there is a specific DevOps session that I have taken. So, for example, you have a kubectl as a command with which you can interact with Kubernetes. So there is a modified version of kubectl where you can directly interact with the natural language. For example, I think there is a cube GPT. Okay, so what you can do is with cube GPT, you can say create a deployment with name DEP1 and with the image, let's say HTTPD. So you can actually give that as a natural language input, and then internally what it does is it actually understands the natural language and converts it into a proper kubectl command using the LLM model, and then that command output will be finally executed on the Kubernetes. Okay, so that kind of tool sets are available. You can just check it. I think one example, as I said, is kubegpt, but there could be many. I've used a few. Immediately, what I could remember is this. Okay, so you can check this out. So that's an example of a tool with which you can you have a pre-integrated tool that directly interacts with AI. So parameter means the data given for the training. So basically, the parameter is not about training. So for example, you have a brain with a lot of brain cells. So let's say 1 trillion brain cells. So each parameter is nothing but some kind of a computation unit within your neuron or within a cell, kind of. That's how you can understand. It's not related to data, because the more parameters you have, you can feed it with more data. But if you have, let's say your brain only has 1/10 or 1/100th the number of cells. So in that case, you can feed it only with less data, right? So which means that the parameter is about computational resource. You can roughly understand like a number of CPU cores in a processor, right? So the more parameters you have, more computations you can do and more information you can retain. So which language it is supporting? I'm not sure what is the context of this question. Mostly these models are written and coded in Python, but you can interact with them in any other language if it is available as an API. Is there any online or offline platform where we can create GenAI POC? See, basically, you can even download the model and do all the fine tuning yourself. For example, you can in general use Google Colab. Google Colab is totally free, where you can learn and load these models and run them. That is all possible. But beyond that, if you want anything, for example, you have things like AWS. There is a SageMaker that is available. Most of the models that are available in Hugging Face, you can actually load them there. And the one common place where you can mostly start looking at is actually the Hugging Face. So Hugging Face is actually a very big model library. If you look at the models here, so for every purpose, there will be a model. So for example, you can see you have an image to text or a text to image. So where you give a textual description of what you want, and the model will create an image, generate an image for you. And you also have text to video, text to audio, right? So you have voice generator. So and you have text to speech. You can see that here, right? And so on. So basically, there are a lot of models that are available here. And also, if you go to the model documentation, they give you information on how to use these common models. Okay, so for example, let's say I go to the transformers. So if you go to the transformers in the documentation, they specify what are all the models available, in which platform they are supported, etc. Okay, so they have a lot of information here, and how to perform an installation, a quick tour of what are the models and how to run them. An example is given here. Okay, so for example, if you want to do a sentiment analysis, so just 2 lines are sufficient. So run from transformers import pipeline class equal to pipeline and then just sentiment analysis. Now you can use this classifier and give a text, and you will directly get to know whether it is positive or negative. Right, just 3 lines of code, and you have a LLM model you can directly run. And mostly you can actually even the installation step is also given here. And so you just have to run this command in a Google Colab environment and run these 3 lines of code, and you have a LLM model running predictions directly, right? So very easy to get started if you use a Hugging Face here. Okay, so I think that should answer your question on building POC. So you can, again, if you want to programmatically access it in a office environment, you cannot use Google Colab, then you can go for AWS SageMaker. That's something that you have to pay for it, but you can use it as a company, right? And you have a lot of documentation on SageMaker, how to use it and how to get started. There are enormous amount of information there. Fine. So I'll give some sample prompts. I think I should have some time for it. And let me see. I'll give these prompts as well. Maybe I may not have time to run all of them. I'll try to see. So for example, classify this review. 0 shot, 1 shot, some examples are here. And then there should be some option where you can have advanced prompts. So for example, these LLM models have been trained with terabytes and petabyte amount of data. They have huge capacity. But sometimes the questions you ask, it may not give you directly the relevant answer. So in that case, how do you do? So there are ways in which you can actually say, reverse the pattern. So for example, I can say, I'm going to ask you a question, and you instead of you asking the question and LLM answering, you are asking let's say you want to know about something that you don't know. So you don't have any idea about law, but you ask, you want to know, given a situation, who is the culprit? How will the law interpret it? So in that case, what happens is, in that kind of a situation where you want to know about something that you have no idea about, it is better to leave the question asking to the LLM. So now you can say the LLM, you tell me what are all the relevant information I should provide for you to give me a more accurate answer. And now the LLM will give me this information, and it asks you 10 questions. So now you can use those 10 questions to actually give a better, and you answer all those 10 questions. Now the LLM will combine all that information and produce a final output. Okay, so that kind of a reversal is possible. Okay, so I'll see if I can show you some examples of it. Latest code. Okay, so I think I should have one or two prompts like that. So for example, that is called as one of the options is cognitive verifier. So I'm saying when I ask you a question, generate 3 additional questions that would be relevant. So I've given 3 to keep the response small, but you can actually increase it. Okay, so ask it to generate 10 or 20 questions that is relevant to give me a more accurate answer. So when I have answered all the questions you have given, then combine those answers from me as well as the original question to produce a final output. Okay, so this is what I'm going to say, and I will give it to ChatGPT model. So let me see if I can go back to the GPT tab. Yeah, so here, let me paste it. So now this model is actually trained to understand and keep things in memory. So you can see that it says memory is updated. So what it does is all the previous questions in the entire chat interface, that chain, it actually remembers. So that if I now give an question like what are the as of with around 5 years of experience as a Java developer, can I become a data scientist? Right. So a lot of people have this question. So that's the reason I'm putting that. So in that case, what happens is the model will try to ask me 3 questions because it remembers that this question it has to combine with this information. So now it asks me 3 questions which are relevant to that particular use case. Okay, so now what I can do is, because I don't know what are the skills, what is the information I have to give to the model in order to generate a more accurate answer. I don't know. So in that case, what I'm doing is I'm leaving that even asking the right question to the LLM. Okay, so now the question is what specific areas of data science are you interested in? I would say, for example, artificial intelligence and for example, generative AI. Okay, so generative AI. Okay, so that's what I'm interested in. So do you have any experience or knowledge in data science related fields such as statistics, data analysis? Yes, I worked with data visualizations and generating reports. Okay, so these are the 2 things that normally an application developer will do. Right. Lastly, are you open to pursuing any course or skill reskilling, etc.? Yes, I can take up, let's say, a master's course. Okay, so that way I have a lot of time to actually learn, right? So that is what I'm going to say. I'm going to answer all these 3 questions. So now what happens is, now the LLM actually understands the answers for each of the questions it has asked, and it is going to combine with this question, and then it's going to give me an answer. So it says that given your interest and your ability to work with data, most likely it should say, I can, right? So that's what it should finally summarize as. So you can see this is an example of a more advanced prompting, right? So by looking at prompt engineering a lot. So if you initially, if you are very new to generative AI, I would suggest you to look at different prompting techniques. So there are several prompting methodologies that are available. So what I showed you right now is actually called as a cognitive verifier pattern. Okay, so apart from that, you can actually ask the LLM model to take a specific what do you call? So basically, role. So that is called as role play pattern. And there are patterns like recipe pattern, and there are reasoning and action pattern, etc. Okay, so I think there is a very simple use case that I can actually show you, and that should be available here. So chain of thought. So that's again a simple thing. So that is built within the system. So chain of thought is nothing but, so even as a human being, some questions you cannot even answer within one single processing flow. So you have to do multi-stage processing. So that's an example of chain of thought. So you take the input output from the previous stage and give us input to the next stage, and then you process further. So that is called a chain of thought. You can see my question is I have around 5 boxes in my car, and I can take 10 trips per day. So how many days do I need to ship 200 boxes? So that's the question. So if you can see that it is now doing a proper cognitive verification, right? So and based on the verification, now it splits the processing into multiple stages. So first it says in one day I can take 5 boxes, and in one trip. and I can take 10 trips. So in that case, per day, I can actually ship around 50 boxes, right? So that's the first thing. And with this 50 boxes input per day, now for 200 boxes, how many days? So 200 divided by 50, that's 4 days, right? Even our thought process is the same. So this is called a chain of thought, and these models are actually built with that capability by default, right? So that's an example. So which means that these models are not just trained on text alone. So they have internal ability to, and there are several prompt patterns that they are trained to actually understand. Okay, so that way what happens is they are much more powerful. Okay, so if you can look at more of those prompting techniques and prompt engineering, if you learn, that will be giving you a lot more power to generate much more complex things than just asking questions and the model giving an answer. Okay, so I've shown you a couple of prompts. One is chain of thought, the other is cognitive verifier. There are so many other patterns that you can learn, and also I have given zero shot and one shot and few shot learning examples also, right? So what they are. So that's end of the presentation, and I have some more details. I was thinking about covering image caption. I think I will show you RAG. So RAG is information retrieval, which will be more relevant to you. So I'm going to show you that I'm going to use a Google Colab notebook, and I think I should have one notebook that I created for my previous session. It's the same RAG example. I'll try to show that to you, and then I have a few more slides related to ethical AI. That will be the final topic that I will end. And in between, if you have any questions, I will try to answer them as well. So I'll take a couple of minutes to show you an example. So what I'm going to do is I have a sample data, which is here. Okay, so this is an example from a GitHub learning resource for generative AI. So what it does is it actually has information about the Senate discussion, like our Parliament, US has the US Senate, and there were some discussions, and so they have discussed about, for example, Ukraine. Right. So, what is the support that US has done for Ukraine? For example, they have given Ukraine around $1 billion of aid and more. Okay. So apart from that, they also have some healthcare related discussion. So you can see there is a health insurance related discussion because US healthcare bill is enormous, and US government is spending in trillions to actually support the healthcare bill of the people. Right. So there were some discussions related to that as well. So we are going to see some information about all this, plus a lot more information is here. So we're going to ask some questions. So similarly, in your enterprise, you have some details about your project. So you can take that project data, put it into a file. Now you can actually run a RAG on it. So that's what we're going to do. So I've created a new notebook file, and I've installed the dependencies. Every time you open a notebook, you will have a totally different environment. So which means that every time you open a notebook, you have to install all the softwares again and again. I've done the installation. So these are the softwares that are necessary to perform LAG. So mainly we are using LangChain. And what we are going to do is we are going to perform information retrieval. So I'm going to feed this text file that I showed you here into the model. And so to do that, I'm going to use, you can see that here. So for example, let me see if I have that exact same file, or I think I may have a different file. Let me just check. Yeah, State of the Union. So that's what I'm going to load. So from this link, I'm downloading the file and saving it into a local text file called the State of the Union. And then what I'm doing is I'm using a text loader, which is available from the LangChain library. And what it is going to do is it's going to make it convert the text into format that the model can understand. We are going to do embedding as well. So that's what we are going to do. So you can see we are splitting the text into smaller chunks and then load it into some vector data. So using some embedding model. So that's what we have done here in these 3 lines. I'm not getting into the code much. And you need, if you're using any LLM model, so you need the API key to access it. And so I'm using one of the keys that I have locally, which is provided. And I'm actually going to do the embedding. You can see that the whatever text we loaded, those text document data, we are converting into embedding format, and then we are combining it with the LLM model. So now this DB1, which is actually the retriever, we are going to use it as a retriever. So it is having the LLM model combined with the document data that we have from the text file. So now using this text retriever, now if I ask any question, then from this retriever model, the information will first fetch the relevant details from the text document, feed it to the LLM model, and the LLM model will combine the information from the input text plus the data, and it will produce the answer. And I'm using a slightly older model, GPT-3, to keep the cost low. And let's see the output. So what I'm going to do is I'm asking a question to the retriever. I'm saying that how much can a family save if the American Rescue Plan is implemented? So for example, the American Rescue Plan details are actually there in this particular document. So you can see that they're used by these people and etc. Some information is there. So I'm going to ask this question. So let's see what this model is going to say. So it says that the exact amount of the family can save will depend on many factors, such as, for example, the family income, household size, number of people in the family, etc. But I think it is fairly accurate to give the information from this document. And one more information is I'm going to ask, in what ways did America support Ukraine? Because there were some information about Ukraine as well. So let's see what is the output we see. So it says that America is supporting Ukraine with several ways, including, for example, with a aid of more than $1 billion. Plus, they also give arms and ammunition and improving governance, etc. So they have given a lot of information here. But you can clearly see that the model is fairly accurate enough to answer exactly the question as per the document that is present there, right? So that's a demo of retrieval information. So which means that you put any technical document into the model, and now you load that into the model. Now you can use the same code, just change this document to something which is of your interest. Now, finally, you ask the questions that are relevant to your field, and the model will directly start giving you answer. So, for example, even if you're totally new, there is a newcomer who joins your company, and they don't have any idea about your project. So now what you can do is you can load all your project information, documentation, text, user requirements, everything. You put it into this LLM model. Now he can actually, similar to how he will converse with you. So, for example, he asks what is the requirement, what is the client, when was this something signed. Now all those questions, instead of asking to a human, now you can actually converse with the AI. So now AI will look into the past information that is fed into the document, and then based on that, it can directly answer a question. So which means that you can remotely train people, right? So that is a need of the hour today. So you can easily build a RAG system. Now your juniors can actually look into your converse with the AI to actually get all the information they want, right? So these are some of the ways in which you can straight away use AI. So finally, I will just take one more minute to answer some details about give information about ethics, and with that, I will keep last a couple of minutes for any further questions. Okay, so AI models will have some limitations as well. So, for example, AI models will have out-of-date data. So, for example, if you ask the question, who is the British Prime Minister, it will say Boris Johnson instead of the current British Prime Minister, because the GPT-3 model, when it was trained, it has only old data. So now what happens is the GPT model 3 model was trained in 2022, right? So one way to fix that is you can actually use again LangChain agents, which can actually look into the internet and identify who is the current prime minister based on some common verified sites, and then give you an answer. So this behavior was updated recently, around a couple of weeks back. So which means that the LangChain agents, which can look at, so do a Google search and find the answer, that is implemented in the GPT. So if you now ask a question, so the model will straight away say that whoever is the current prime minister, it will directly give the answer instead of it will not even say Rishi Sunak, because I think the election results just happened a month back, but still it will give you an accurate answer. Okay, so that feature was recently introduced. So these models look like and think like human brains. So that's the reason if as a human being we cannot do 10 number divided by another 4 number, we cannot efficiently do that in our brain. And similarly, LLM model is also not capable of doing that, and it will give you a ballpark number close to the original number, but it will be inaccurate to a small extent. Okay, so what is the way to fix it? Again, you have a LLM agent, which is actually a math agent. So you can actually integrate math agent into the LLM. Now, similar to RAG agent, now you can actually implement a math agent. And the math agent will actually do the mathematical calculation and give you the accurate answer. So last part, actually, one of you asked the question, what is hallucination? So hallucination is nothing but, so for example, you have a code which is written in Java that the model has seen. Now the user is asking, give me the same information, but for example, in a different language like Golang. So now what happens is the model cannot say, I only have been trained with the Java, I cannot give the information in Golang. Instead, if it knows what is Golang, it knows what is the syntax, it should be able to convert the information into the target language user is asking for and give it. So which means that the model should be creative enough to generate something it has not seen. But this becomes a problem. So how does it become a problem is it could actually make up things that may not exist, which is physically possible. Okay, so that is called as hallucination. So hallucination is nothing but making up things that is not feasible. So an example is if I ask the question like how will a white color crow look like, instead of saying that there is no white color crow, it will actually describe how it will look like. So that's what is hallucination. Okay, so these are some of the problems that are existing with the current LLM models, and so I think I don't have the time to describe about this, but what we have done is just this. So basically what we are doing is we are combining the user question, which is the input query, with the document which is there in the enterprise. So now the combined information, which is the document with the original data, is fed to the LLM model. So now the LLM model can actually give an answer by looking at the data with which it is fed. Okay, so this is the retrieval augmented generation example that we have seen. And using this, the model can actually really work with user data instead of just working with its own pre-trained information knowledge, right? So some more detailed information about RAG is there, which I'm skipping now. Okay, so there are some agents that are available, LangChain agents. So for example, as I said, math agent is one, wiki agent is another, which can actually look into data from wiki. There is also a Google search agent. There are tools which can load data from different databases, and we have prompt templates and memory. Okay, so these are all the components that are there in LangChain, which can help us integrate the LLM models with the user code. Okay, and I'm just going to go into the ethical part of it. Okay, so there are some problems that the LLM models have. One is toxicity. So the model could be biased against one particular ethnic group or people or country, right? And it could have hallucinations as well. And it could also generate content which might have intellectual property, which are, for example, copyrighted information. Okay, so these are some of the challenges that you have. So example again, so sometimes what happens is the model has the knowledge about the answer, but it cannot give. One such example is, for example, I asked the question, how to hack my neighbor's Wi-Fi, right? So definitely, if it has looked at how to do hacking, it knows the answer, but it will not give me the answer. Let me show the tip. So how to hack my neighbor's Wi-Fi. Okay, so even if it knows the answer, it should not answer. So, and you will see that it says I can't assist, right? And that is the more ethical, proper way of answering things, right? So this ethics actually again is an active research, how to reduce toxicity, how to make the model, because sometimes in the training data itself there could be some toxic information, so you have to carefully curate the data itself. But more importantly, if the user is giving some toxic information in the input text, he is doing vector search, still the model should not give you such kind of information. So there are ways to mitigate it. Some details about it are given here. So again, LLMs are very, very recent technology with a lot of and responsibility. Responsible AI is again one of the things that I showed you right now. A lot of curation is being done, and a lot of active research is happening on ensuring that AI is safe for people. Okay, safe AI research is something that is very active and evolving. Right now, they may not be fully compliant to safety. There are, for example, there are concepts like prompt injection that you can do to make AI reveal things that it is not supposed to. Okay, so and the people are still working to solve those problems as well. But right now, AI comes with a lot of capabilities, also has some challenges, and using it responsibility is in our hands right now. But in the next 1 or 2 years, around $500 billion is being invested globally on generative AI technology alone. So which means that huge leaps and bounds of new activities are going to happen, and new models are going to come with a lot more capabilities, and they'll surpass human level understanding and human level cognitive thinking in another 5 to 6 years is what is expected. Okay, so at that stage, the whole world will be totally transformed from where it is now. Okay, and programming might even be totally redundant, and we may just have to give the input on what the model has to do, and the application generation, pushing it into production, running the model, monitoring it, troubleshooting, everything mostly the AI will take care in another 5 to 6 years. So that's the kind of future we are looking into. So I think the session was useful. Let me know if you have any questions. So there was which language? I think there were no questions after the 6 p.m. Yeah, go ahead. Please, if you have any questions, please go ahead. There's a hand raise. You can even unmute and discuss, and you can also use the chat. Both ways, it's fine. There is a feedback link given to you in the chat. You can please try to fill the feedback form before you drop from the call. And is generative AI. So how to fine tune an LLM model using custom data sets? I have some programs associated with it. I'll try to share it. So is generative AI core infra be deployed on premise for a company network alone? We can do that. So for that, you have to know how to download and run the AI model. Probably I will try to suggest you to go with something like Olama. So just check for Olama. That will give you an idea of how to easily get started with running a LLM model locally. Okay, so this is the one that you can check in case if you want to run locally. So there are a few more questions. Which Azure LLM model is good for improving business presentation and report? See, I think even Office 360 has their own plugin, where they have integrated with Copilot. You can straight away try that. It will automatically generate the entire presentation for you. Okay. So what technologies be used to create a GenAI solution? Most likely Python, TensorFlow, PyTorch. These are the things, and you have to have a deep understanding about these models and deep learning, etc. So how is Chroma compared to it? Okay, so that's very technical. I will skip that question now. Fine. I'm sorry, I have extended the session by 5 minutes. Pretty much, I think that will be end of session today. If you have any questions, I'll still be happy to answer a few more. And please ensure to fill the feedback form before you leave. Thank you, everyone. Hopefully, we'll again see in one more session. Let's see.
Thank you, delegates, for your participation. We hope you all had substantial takeaways from the session today. The session recording and a copy of the reference material will be made available to you on our website. Please refer to the same by tomorrow. Thank you once again for your time. Have a wonderful evening ahead.
Hi, Sai. This is Devanshu here. I have certain questions. This
Yes.
time format to laptops. Okay. So first thing is like you said about the size of the model. So what actually is contained in a trained model? Like the training data, I understand the size of it and the back of the envelope estimations that was stored. But what actually the model size depends on? Is it only the training data, or like even SLMs might have size more than the LLMs?
No, so the size purely depends on the network structure. So, for example, the neural network, they're ultimately large language model is nothing but a deep learning neural network model. The way the network is designed is what determines the size. And roughly the idea is, for example, the more parameters a model has, it can understand more data better. Okay, so for example, you have a billion parameter model. If it can be trained with 1 terabyte of data, let's say 100 billion parameter model can be trained with more data. Like for example, even 100 terabytes or even 1 petabyte. So which means that the more parameters you have, the more information it can retain when the model is trained. Okay, so that's how you can roughly understand. But
So
the more parameters it has, it also will be more expensive to train, and it will take longer to train those models.
okay, so a higher trained data would have a higher storage layer associated with it. Is
Correct.
that an info? Okay.
Yes.
And one more thing, do you have any suggestions regarding learning about agentic workflows? Because the agentic workflows that you explained, like having a separate agent for Google search or a math agent, is currently irrelevant, right? With the introduction of newer models, I think those are inbuilt. So to achieve
Yeah, so for
the
example, there are multi-agent flows that are available, and yes, default the platform itself comes with some pre-agents, pre-integrated, etc. But yes, so the more agents you know, and if you can develop your own agents to do certain tasks within your organizations, you will have much better way to control how the LLM can be integrated with your product. Fine. Shortly after the session now, I'll upload all the material used during the session. Okay. Thank you, everyone. If there is any 1 or 2 questions final, I'll take. Otherwise, we are good to drop.
We're good, Sai. Thank you so much for your time. Have a wonderful evening.